For years, outer space has been a source of intrigue, inspiration, and imagination for many. Here at IQT, we harnessed our intellectual curiosity and perspectives on the commercial space industry years ago, and continue to be interested and invested in how space ecosystem develops in the future. While it may seem like the stuff of science fiction, it is not too far-fetched to imagine robots mining the moon for resources and raw materials, or a lunar economy based on out-of-this-world manufacturing, or even a family vacation among the stars. Maybe even one day, we might be able to see what spring is like on Jupiter and Mars. Welcome to the IQT podcast. Today's episode concludes our three-part intro series where we explore how IQT space investments and insights have helped advise and shape the technology to help enhance national security and beyond. On our previous two episodes, we covered the origins of IQT space efforts and current initiatives and focuses. And on today's episode, we'll focus on what we predict the future will look like for this ever-evolving domain. I'm your host, Vishal Sandesara, and I'd like to welcome back Kristi Bradford and Tom Gillespie, who we heard from our previous two space podcasts. Kristi is a senior technology architect on IQT's Field Technologies team. She's a space technology strategist with experience working across the civil, commercial, national security, and international space communities in areas as diverse as technology development, program management, space innovation policy, and the global space investment landscape. Tom Gillespie serves as managing partner on IQT's investment team and as investment lead for IQT's Field Technologies practice. He has led a significant number of IQT's investments in commercial space ventures over the past 7 years, including launch vehicles, small satellite constellations, space situational awareness, and satellite componentry. And new to the IQT podcast today is Clayton Williams, a managing director at our IQT Australia office headquartered in Sydney. Prior to IQT, Clayton developed innovative signal processing approaches in support of the NRO, NGA, and U.S. Navy to address space domain challenges spanning product quality, automation, processing, and distribution. Kristi, Tom, Clayton, welcome to the show. Thanks for being here today. So let's get started. Today we're talking about the future. Might be worth discussing what we really mean when we talk about the future. Are we talking about a year, a few months, weeks, a decade, a millennium? Where is it that we're going to focus our discussion and scope our topics of interest today? Open question to all of you. Let's start with Clayton.
Yeah, I think it's kind of a dangerous topic, especially for a 20-minute podcast, because you can get anywhere from Star Trek to just trying to get the nuts and bolts of manufacturing down. But I think for this conversation, scoping it, I think we can probably give an interesting story on the next 10 years or so of what might be coming down the pipe in space.
Great. Focus on it. So we'll set the scope to 10 years from now. So it's 2021 right now, 2031. Between now and 2031, for those of you listening, we're looking over the next decade. Let's start by talking about business models. Tom, we've discussed a lot in the previous podcast about the existing business models and historical business models. What do you see in the landscape for the next 10 years in terms of things that'll stay the same, things that'll evolve? What should we be looking out for?
Yeah, it's interesting. Yeah, and just in terms of the time horizon, I'm coming at it really from the investment standpoint. So from a venture capital time horizon, funds are typically about in that 10-year range, really making investments though over the next 5 or so. So that's almost kind of more how I'm thinking about it in terms of the future as an investor. What's going to change in the next few years? I think we'll see a migration to business models with more commercial baked into them. When we first saw commercial space a few years ago, there was some lip service around that, but really the reality has been the last few years more of a focus on government markets. I think that'll start changing in the next couple of years. I think we'll see a lot more investors spill into this sector. Some will come in and come out, but I think it's going to be a much broader set of investors. And I think we'll see interesting funding mechanisms along the way too. I've seen things like interesting uses of markets to fund alternative strategies. So I think we'll see some innovative financing strategies as well along the way here.
Excellent. Thanks, Tom. Question to Clayton or Kristi. So Tom mentions this shift from a focus from government funding to commercial funding, interesting developments and capabilities leaning in that way as well. Where do both of you see requirements coming from? Who's going to be driving the requirements specifically? What will this look like? How will we see commercial industry sort of take a leading role in developing capabilities in this space, pun intended?
Yeah, so I think it's going to be very much a combination. Well, I think we will see a shift to more commercial, as Tom said. I think that government's still going to be a really critical component to the ecosystem. And so, but I think we're going to get a better balance, especially as a lot of these companies begin to deploy their full constellations and start to explore product offerings that are more commercially oriented. Whereas the government side, there's already proven demand there because the government has been leveraging similar technologies for so long. But it's hard to really understand what the demand is on the commercial side until those capabilities are on orbit and can actually be proven out and products developed around them. And I think we're going to see that product development really happening in the next 5 years.
Yeah, I think to kind of emphasize what Kristi was saying is the number one customer for remote sensing, certainly, and I'm sure it's a significant split of comms as well, is the government customer or government's customer. And the long-term justification of all these competing commercial endeavors, it'll be interesting to see, who these governments are able to support and which companies are able to pivot enough of their business to sustain it commercially. And when we say commercially, it's interesting, right? Because we actually just saw an article yesterday from CNN that's basically watching the build of the launch site in the Arctic from the Russians. So these kind of missions that were fully in the government domain are kind of shifting over into news articles, NGOs, and different folks that have kind of these worldwide regulatory or policy or news type of missions. And then I think that the next phase to that is big agriculture, big business, all these kinds of oil and gas, all these big industries that really can benefit from remote sensing and tracking large areas and large systems. As the cost of space comes down and as these analytics companies can actually flesh out their products and make them reliable and useful.
If I could join in, I think synthetic aperture radar is an interesting example of, it's pretty illustrative of the government versus commercial. When we first saw these companies, probably 5+ years ago, they were ostensibly going to be commercially focused. They weren't really able to do that early on. And so I think they pivoted back to government markets for a while. What we're seeing is that I think over the next few years, SAR data is really tough to work with. There aren't a lot of commercial applications for that, but there probably will be at some point. And it really is a case of, getting that data out there, helping the commercial market understand how to work with it and see the use cases for it. And then the market's going to develop from that. So does the commercial market exist in any form today? Not really. But I think as we start learning how to use that data and the different applications, it's really going to take off. It's just not yet. So.
And I would add to that I think that there's a semi-good analogy that we can look to when it comes to this remote sensing data, and that is how GPS applications evolved over time. Is that when GPS, which obviously was, it was and still is a government program, once it was made available to the civilian communities and people could start using it for commercial applications, then it took many, many years for it to develop into the ecosystem we see today, where use of GPS is ubiquitous and is in basically every industry that you can think of, but it's sort of hidden behind the scenes. Is that I think over time we may see a similar thing develop from remote sensing data, where it becomes used in so many different ways that we often don't even realize that we're using space data in our everyday lives. But it's important to remember, it took a very, very long time for GPS data to be used in the ways we see today, and it's going to take a similarly long time for it to mature on the remote sensing side.
And Kristi, just to provide a sense of scale and comparison, in your GPS example, is it safe to say that perhaps the timeline in GPS began sometime in the 90s, and roughly from then till now, 20+ years or so till mass just ubiquitous adoption and availability? First of all, is that accurate in relation to GPS? And secondly, would you suggest that we're looking at something similar in this regard?
Yeah, I think your timing is accurate. Is that we're looking at about a 20-year time period from when the capabilities started to come online to when we see this ubiquitous use. And so I think we're right now at the stage where we're really starting to see a variety of sensing modalities come online at the level of fidelity and revisit time that these companies have been talking about for some time. And so I think we're sort of looking 20 years out from now, which I get is 10 years longer than we said we were going to address. But I do think that we're going to slowly see over the next 20 years new applications emerge that are going to proliferate the use of remote sensing data.
A quick moment for our audience. Clayton and Tom, you both mentioned SAR data, synthetic aperture radar. For our listeners, could you define just what that is and perhaps what it looks like and what kinds of information SAR data conveys?
Yeah, I'll take a shot at it. It's basically you send an RF signal down to the Earth. You get the reflected signal back at the system, and you do that over time. And what you're able to do is construct a short video or an image of that data as it reflects off of different objects. And so that difference in reflectance can tell you different information about not just the size and shape, but the material properties of the objects you're looking at. And what's interesting about it is that doesn't rely on the sun in any way, so you can get the same image day, night, or during storms. There's an interesting article, I think, from ISI that we can probably share that shows this application while monitoring a volcano, and that's been one of the largest challenge for remote sensing, even from airborne platforms, because you don't want to be anywhere near it. And so synthetic aperture radar is able to provide you that consistent imagery through the smoke, through the cloud, day, night, to kind of track these kind of natural disasters as they occur.
I see. Interesting. One thing that we mentioned that it's that is interesting to me is this idea of we took GPS as an analogous example to sort of what we're talking about in terms of the future of the space ecosystem. This concept of dual use. So we discussed the shift from government to commercial, both in terms of funding and where demand will be coming from and where capabilities will be shaped to cater to. Can one of you describe just what dual use means on behalf of our listeners? Again, this concept of something being perhaps invented in one domain and then becoming useful or pertinent to another domain. A little bit more detail there would be great.
Sure, I can jump in on that one. So dual use, you could define it as simply a technology that has more than one use. But usually when the term dual use is used, it has a specific connotation, which means that in addition to having a military or national security use, it also has some sort of civilian or commercial use. And so that's basically the idea of dual use, is it's some sort of technology that could be used for both national security as well as for non-national security applications.
Very good. Thank you. So let's talk about challenges. This is a podcast about the future. Something that's really interesting to think about and make predictions on are challenges, obstacles, things that'll have to be overcome or hurdles that'll need to be crossed when dealing with this industry as it grows. What do you see as some of the toughest or enduring challenges that need to be addressed, overcome as we enter the future? We'll start with Clayton, and then Kristi, and then Tom.
Yeah, I think the cliche is space is hard, and I think that a lot of the lessons learned from governments over the last 30, 40 years in space may not be fully realized by some of the companies that are entering into this space, and that's from the challenges of the manufacturing, the challenges of launch, the challenges of having a system in space that functions and doesn't break, and then providing reliable software updates to those systems. It's really I think I'm describing like 5 startups when I talk about all the challenges that entails. So being able to do that effectively and efficiently when you have investors who are looking for return on investment is an extremely challenging thing. I think there are a lot of programs in the government that got canceled due to funding overruns, and you can only imagine the pressure is exceedingly higher for these companies.
Yeah, I would add to that I think sort of the umbrella term of space sustainability encapsulates a lot of the challenges moving forward, which is that as more and more activity is happening in space, it presents a lot more challenges, although it also does present more opportunities and does open new types of markets. And that is an area that we at IQT look into. We refer to it as space auxiliary services. And I know I've talked about that on a previous podcast. But to dive into it a little bit more than I did previously, we see 4 pillars of space auxiliary services. The most near term is space traffic management, which I think is a cornerstone to space sustainability issues, which is how do we understand the space environment? How do we track everything that's going on in that environment? How do we characterize what's going on? Be able to detect changes in that environment? How do we make sure that different satellite operators are communicating with each other? How do we minimize the amount of debris creating events that are occurring? How do we deal with debris that is already up there? How do we prevent more debris from being created in the future? And so that's an area that I think is going to be really critical, and is an area that is incredibly complex because you're dealing with such a diversity of actors in space, is that you're not just dealing with US companies and the US government. You're dealing with non-state actors, you're dealing with state actors, you're dealing with a huge array of different players in space, and that diversity of players is continuing to grow over time as more and more countries begin to place strategic priorities on space, and as commercial space becomes more and more international.
Interesting. Tom, any perspectives from you on challenges maybe from the business front, funding, finances?
Yeah, exactly. It's so I think from a funding standpoint, it's going to be interesting. You look back over the past few years, I think one of the things that sort of held the sector back for a little bit was the lack of financial exits, IPOs, acquisitions. There were very few that could be cited. One was Skybox, which was probably 2012 or 13, I can't remember. That was $500 million exit to Google, which sounds like a lot, but really in the venture context, it isn't that much. And that was really the only one we could cite for a long time. In the present, we've now got all of a sudden the special purpose acquisition companies that are exit vehicles for a lot of space companies. I think we've got 10 or 12 now that have gone out in the past year and a half or so. That's great. My question is that sustainable? And, how long does that last? A lot of these companies need a lot of money. The SPAC vehicle is one way to do that. But I don't know if we look forward a few years, if that's going to continue to be kind of the way things go. So I think, that's really an obstacle is where do you get the money to fund these things? And, how available is it? Not just now, but looking out a few years. The one thing I'll say, I do think there will be funding, available over the course of time. I just don't think it's going to be a straight line path of progress. I think we're going to, have moments when we have a lot of funding available, then it's going to fall back a little bit and it's going to recover. But I don't think it's going to be a straight line path over the next 10 years.
And I think it's interesting too that there's probably going to be some consolidation. I think you saw it. There's a ton of innovation that happened in aerospace in the 50s and 60s, and then we all kind of ended up with the same jet body type 747 type plane that we use for nearly all of our at least human movement across Earth. And so I think you're going to see the same thing where you see some really innovative space things happening, but are they the most efficient way to do business in space? And is this, really bespoke sensor that's super expensive, bringing you enough value to justify its cost versus something off the shelf? So there's all these kinds of questions that are going to play out, and it'll be interesting to see how those companies combined go under or get acquired by large players in the space.
Clayton, you're reminding me of something in relatively recent history in my life, and that's the dotcom era, the internet.com era. And Tom, I think you and I have had conversations about this. It's open commentary and thoughts on and perspectives on how similar or different is what we anticipate in the future to occur in the space realm when it comes to companies starting up, getting funded, maybe consolidating, defragmenting, and then operating versus not being able to operate. How similar is that trajectory looking in the space realm as compared to the internet.com era? I'll tell you very simply, looking back at it now, of course, everything was an internet company back then. I recall literally everything I saw anything anyone talked about was like, oh, it's my .com company. This is my new internet company. Are we going to hear the same thing? This is my space company. I'm doing space. And if so, what is it that's going to be meaningful for something to be a quote space company versus might not be so meaningful?
Well, I'll jump in on that one. Just on the question of what is a space company is, I think already it's really hard to define what a space company is, because you could argue that Uber and Lyft are space companies because their business model is dependent upon GPS. Now, no one really categorizes them as space companies, but that shows how ubiquitous space already is that things that we don't even think of as space companies are dependent upon space infrastructure. And in fact, going back to your previous question, I would say that's almost one of the challenges over the next 5 years or even longer, is getting people to better understand just how dependent we are as a society on space, so that they understand why there is so much investment going into space. And I think that's just something that we need to grapple with, because there is this disconnect between sort of those who understand space and understand how ubiquitous it is, and the average person that thinks of space simply as space exploration.
That's a good point.
I think it's also, there's like a double challenge there. One is these companies that are launching, building, and operating space systems. Those are full-time jobs. So you used to hear a lot of the companies saying, we're actually just an AI company, and step one is build and launch a satellite. And I think you're hearing less of that. And to Kristi's point, that secondary market, or those companies, are waiting for the right time, the right price point to develop analytical products on that data as a space company, as a space services company here on the ground, just doing software. So there's kind of this cascading chicken or the egg problem on to the timing of when those constellations will be sufficient enough to build reliable ground businesses off of that data.
Tom, your thoughts on the internet dotcom comparison, the boom and the bust cycle there, and how it may relate to the topic at hand today?
Yeah, it's interesting, Vishal. So I speak to you as somebody who actually started an internet accelerator in 1999, which, if you know the timeline of this, was a terrible time. It was right at the peak. So what I a little bit of what I see, has some of the same markings that we saw in the dot-com economy. It feels a little bit, in some ways, like it's 1997 or so in the space economy. So we're starting to see a little bit of froth. We're starting to see some things get funded that maybe shouldn't. But I don't think we're kind of in full frenzy yet, like we were in the dot-com a couple of years later. I think there are a couple ways that it's different, though. And one is, space has a lot of national security implications, obviously. Consumer internet really didn't have that. And so I think it's, to some degree, that's always going to play a role in how we think about space, whereas the consumer internet in the 90s did not. I also think if you look at the history there, once we came out of the bust, there are a lot of good companies that got formed that were based on the internet and did interesting things, but ultimately we're just good businesses, period. And I think we'll see some of that too as we work through some of the bumps here.
I would also add to that hype cycles are something that we see all the time in new technologies as they're coming online and being adopted. And so the dot-com boom and bust is a perfect example of a hype cycle. And so I think we are in a hype cycle right now around space. And I think we are going to eventually, hit the trough of disillusionment, as it is called. But I don't think that, when that happens, that means that, commercial space is dead and we need to go back to government-only space. It's sort of a natural part of the process that this hype occurs ahead of the time that it takes for technology to mature and proliferate through a population. And so I expect, as Tom said, that we are going to see a dip in the future. Exactly when that will be, hard to say. But when that dip happens, I think you're going to have some people sort of trying to abandon commercial space. And I don't think that's the right move. I think, there's a longer tail here that we need to watch play out.
Predictions worth tracking, certainly. Even with the hype cycle, I'm going to assume that it's important for the U.S. and the private sector to continue to care about developing space capabilities. At In-Q-Tel, of course, we have believed this for quite some time. And in case you haven't listened to the previous two podcasts associated with this topic, please do so. You can find those on our podcast page. My question to all three of you is that, do we continue to care going to the future, we as in the U.S. and the private sector, do we continue to care about this industry for the same reasons that we've talked about in previous recordings and historical discussions? Or do you presume that there would be other reasons and other perhaps profitable, lucrative, or strategically important reasons for the US and the private sector to continue to develop space capabilities? In other words, is what we care about this industry going to remain the same, or will there be other things that we care about going to the future?
I think maybe I'll touch on the government side and maybe let Tom talk about the commercial side or the expansion of what the government cares about that kind of tends on the commercial side. The government's been in the business of picking winners for the past, since the inception of space. And so now it's a different game where they really need to develop a common set of standards and endpoints and processing mechanisms to generally accept this data to really have the maximum value from commercial space. So if you decide to pick a winner, then you have one out of the 10 competition or competitive companies in that space. But two, if you build a common interface and pay a small amount of money to those companies to develop that interface, now you have 10 times that capability, and you're really a best customer. And then those things that I think were talked about in the earlier, the passive space is kind of that revisit rate is really important. The ability to have time series data over time. So leveraging as many sources as possible is kind of a new game, a new mindset for certainly the U.S. government, and how to contract to that and how to sustain these businesses, but not be the sole sustainer of these businesses is the inflection point that needs to be hit.
I just want to foot stomp that in that I think it really is important that the government start to take a sort of agnostic technological view of their engagement with commercial, so that it isn't just we've picked the winners and we're now dependent on those companies, but it is this we can have any commercial company plug in to our workflows, so that if a company fails, that the government's not shit out of luck because now they don't have a capability they're reliant upon, but instead they have a portfolio approach to how they're thinking about commercial.
And Vishal, from the commercial side, I guess first I'll answer something that's not commercial, which is we're going to continue to care as a nation because our adversaries do. So they're up there, they're creating capabilities in space. So the United States is going to care on an ongoing basis about the space sector. On the commercial side, we're going to continue to find new ways to do things in space, new opportunities. As Kristi pointed out, where they're comment about space auxiliary services, the more satellites they get up there, the more activity that happens up there, the more opportunities there are going to be commercially to support that. In addition, we'll be able to find new things to do with remote sensing. We'll go further out than just kind of low Earth orbit and nearby Earth. It's going to be assist lunar economy and beyond. So, it's going to take time to get there, but absolutely, the commercial markets are going to develop alongside that.
Yeah, and I think touching on that, it's increasingly complex, and so all the systems to make that happen need to be in place. So it's not just about having computer vision algorithms on your optical systems, but now that whole computer vision architecture needs to be built for, we talked about synthetic aperture radar or hyperspectral or all the RF companies that are being formed and doing interesting things in space. And I think really innovative companies like Spire are trying to maximize the capabilities of their constellation. So now you're seeing one satellite that can do 10 different things simultaneously or near simultaneously. And so trying to understand how to fuse that data, how to get it to the ground, how to process it and out to customers in a timeline that's reasonable is all a lot of hard work that needs to be figured out.
Yeah, I would add to that I think one of the biggest changes we're going to see is a fundamental change in the space data ecosystem. Is right now it is fairly siloed, and it's each sort of company trying to figure things out themselves. I think especially with the entry of companies like Amazon and Microsoft coming in with cloud computing for space, as we see a different way of thinking about how we're doing onboard processing, how satellites are communicating with each other in space, I think that the entire data ecosystem is going to evolve to something that I'm not sure anyone can fully even imagine right now.
Tom, Kristi, Clayton, our time is almost up, but before we drop off, a fun question for all of you to consider. Would you go to space in the next 2, 5, or 10 years? We've been talking today about the 10-year time horizon when considering the future. space tourism certainly is something that is interesting currently, as we've sort of heard about the billionaires in space. Barring cost concerns, if you were all faced with the opportunity to go into low Earth orbit within the next 10 years, would you or would you not go? And why or why not? And we'll start with Clayton.
I guess I'm maybe the pessimist, or it doesn't. The answer is no. Not 2, not 5, not 10. I'd rather be on a sailboat.
Very good. Kristi?
I guess I would say I don't think it's fair to say barring any financial concerns, because in my opinion, that's actually one of the challenges that the space sector has had for so long, is that it's all been about, well, what can we do, rather than, well, what can we do within the cost constraints that exist and the economic constraints that exist. And so I think once you put that into the equation, which is a really important part of the equation, then maybe I would be able to afford to probably not go into space, but maybe a suborbital, or not go into LEO, but maybe a suborbital flight within 10 years. But to be honest, I don't know that IQT pays me enough.
Tom, you want to be a starman?
So I'm the opposite. Yeah, I watched the first SpaceX manned Dragon capsule launch, I guess a year ago or so. And when I saw that, I was saying to my kids, "Man, I'd love to do that." And they looked at me like I was nuts. But so absolutely, it probably depends on the company. I think if SpaceX is offering a ride, I'd probably do it sooner than maybe some of the others. But I'd go.
Okay, so we've got a no, we've got a maybe, and we've got a yes. I'll throw my hat into the ring. I'm a yes after a certain amount of time. I have a hard rule. After I got burned by the great CD-ROM wars of 1995, I bought a 2x CD-ROM reader, and then like a week later, a 4x came out, and then like a month later, a 48x came out, and I was stuck with this 2x for like 7 years. It was the worst. So for that reason, I follow the following rule, which simply is whenever something newfangled comes out, wait 5 years, because it's going to be way better, way faster, way cheaper. My prediction is that we'll see something similar when it comes to space tourism. Tom, Kristi, Clayton, thank you so much for your time today. I've had a great time discussing the next 10 years of what the future looks like in the space industry and the space ecosystem. To our listeners, in case you want to learn more about what we've talked about today, I can point you to the other 2 podcasts in this series. You can find those at the IQT homepage. In addition, we've got a handful of blogs about our space efforts. You can check those out at the IQT blog at iqt.org/blog. Thank you all for listening. Thank you to our guests for being here. And we look forward to talking to you at the next IQT podcast. Take care now.